Myself, Sachin Deshmukh, working as Assistant Professor in the Department of Civil Engineering of Walchand Institute of Technology, Solapur. Today, we are going to learn the concept of hydraulic gradient line as well as total energy line. So, at the end of this session, you will be able to elaborate the concept of hydraulic gradient line and total energy line. Mostly we call this as a HGL and TEL, and also you can solve the problems on this. So let us see. Just see this figure first, all of you. So this is a pipeline and over which the piezometers are attached. Now first of all we'll see about the hydraulic gradient line. Consider a pipeline carrying a liquid from one point to another point, and the piezometers attached to this pipe at any random point. The liquid rises in the tube. You can see here, the liquid rises in the tube. So this level, so there may be many piezometric tube you can attach, and this line, particular line, okay, this line, if you can join, see here, okay, if you can join these points, we will get a hydraulic gradient line, in which we are going to add the datum head also, okay, the datum head, whatever the datum is given, okay, suppose it is here, so this plus this one, this is your hydraulic gradient line. Here also this datum head plus this one, so datum head is denoted as Z, okay, and the pressure head, this is a pressure head, okay, P by gamma, that is specific weight, okay, P by gamma, that is specific weight. So it is a head, pressure head. In many of the books it is P by W. W is also a specific weight they have taken into account. So P by W or P by gamma plus Z is your hydraulic gradient line. Now what will be the total energy line then? Total energy line, here I have drawn, this is the energy gradient line or the total energy line, and here I have written that is V square upon 2G, which is we can say velocity head or kinetic head. Particularly we see this difference in the Bernoulli's verification of Bernoulli's theorem, in which we are having some number of tubes like 7, 9, 11, 13 like, and once we start the flow, we can see the level of the water which is rising in the piezometric tubes. We join these lines with the given pressure head, that is a hydraulic gradient line. So hydraulic gradient line, it is a, you can say, addition of pressure head plus static head. Now just see here, the topmost line is a energy gradient line, or we can say it is a total energy line, and in between this it is a head is V square upon 2G, which is a velocity head. Two reservoirs are joined. Okay, the same thing it is written. If we place many piezometers along the pipeline at random locations, then the line joining the liquid levels in the piezometers indicate the variation of the piezometric heads along the whole pipeline. This line is called as a hydraulic gradient line. The hydraulic gradient line, or we can say hydraulic grade line, in simple way also we can define the line joining all the liquid levels indicated by the piezometers connected to the pipeline throughout. Now this is most important figure. If HGL, hydraulic gradient line is above the center of the pipeline, above the center of the pipeline, the pressure is positive. The pressure is positive, and if it is below, it is below, then the pressure is negative. See here, all the details are given. Reservoir A as well as reservoir B, reservoir A and reservoir B. So many losses that you are also knowing um, when we have gone through the flow through pipes, that major loss, minor loss. There are different types of minor losses are there. Major is by friction, minor is entrance, exit, change in the diameter, many. So here entrance loss is shown. Then you can say hydraulic gradient line is shown over here, and this dotted line is a total energy line. In between this, it is a V square upon 2G, and this is P by W. I told that in many of the books, it is W. It is nothing but a specific weight. Okay, so P by W, and it is up to the, you can say, head of piezometers, and above that the kinetic head, or you can say velocity head, it is V square upon 2G. Okay, this is a datum line. This is a datum line. So here to here, this is the hydraulic gradient line, and above that you can add V square upon 2G into that, you will get the total energy line. Total energy line. Okay. Exit loss, just remember V square upon 2G, and entrance loss is 0.5 V square upon 2G. And this is a total loss, you can say. This is a frictional loss, HF. Okay. Now again, what is a total energy line? When the velocity head at a section is added to the piezometric head, then the total head of fluid at that section is obtained by the equation, that is P by W or P by rho plus V square upon 2G plus Z. Again, we can define the total energy line or energy grade line is defined the line joining the points representing the total head. Total head. For ideal or non-viscous fluid, there are no losses. Hence, total energy line for that point is a horizontal line itself. But for real fluids where viscosity is viscosity is present, it will always sloping down, which is always sloping down in the direction of flow, because the energy must decrease in the direction of the flow. We'll solve a problem on this. While solving the problems, you have to recall the formulas first, okay, so that it will be easy to solve the problems. Now see, and always you have to read the problem twice. A pipeline 300 millimeter in diameter and 3200 meter long is used to pump 50 kg per second of oil whose density is 950 kg per meter cube, and 3950 kg per meter cube, and whose kinematic viscosity is 2.1 stokes. The center of the pipeline at the upper end is 40 meter above than that of the lower end. The discharge at the upper and the discharge at the upper end and is atmospheric. Find the pressure at the lower end and draw the hydraulic gradient line and also the total energy line. Okay, now just see, first of all, whatever the data given, that you have to write and find out discharge, then kinematic viscosity is given to you. Convert that kinematic viscosity in meter square per second. Height of upper end is 40 meter. Pressure at the upper end is atmospheric. Okay, is atmospheric, that is taken into account 0. Now we must know what is the Reynolds number. Okay, VD upon nu. So find out Reynolds number. Reynolds number is 1062.8. Okay, as the flow of oil through the pipe is laminated, we know F is equal to 16 RE. Put this value. Okay, we will get F, because this particular F is required to find out the frictional loss. Okay, So 0.015, HF is equal to FL V square upon 2 GD. So HF you will get 18.05 meters of oil. Then put these values in the equation total energy. Okay, by putting these values in P1 upon rho g plus V1 square upon 2g plus Z1. Similarly on the second end plus HF. Put these values, we will get, okay, we will get here as 0, and here we have drawn, okay, V square upon 2g is 0.0282 and P1 upon rho g is 58.05 meters of oil. Okay, this is the diagram, total energy line, hydraulic gradient line that we have to write, because it is atmospheric, so it is given as 0 P2 upon rho. Some of the review questions are there. Energy gradient line takes into consideration following are the options. And the hydraulic gradient line, similar question, but the contents are different. Which of the following is true? The vertical intercept between the energy gradient line and hydraulic gradient line, and the slope of HGL will be. These are its answers. Okay, go through it. These are the reference books, and solve more problems on this.